Okay, let's move to the next example, which is the example 2. So let's read the question carefully and please pay your attention. Okay, the synchronous generators are shown in figure below with sub-transient reactance of 10%, 15%, and 50%. So this is 10%, 15%, and 15% respectively. So balanced three-phase fault occurs at point F. So the balanced three-phase fault occur at this point. So this point where the fault happens. Okay, so this is the point. Right, next, assume base MVA is 50 MVA. So the question MVA is 50 and transmission line voltage base is 11 kV. So we know that already. The S base is 50 MVA and the V base here is 11 kV. Alright. Okay. Find for MVA. For MVA, the MVAF. Okay. And the fault current. Fault current is IF. Right. Okay. Where each base for G1, G2, and G3 are given as 10, 20, 20. And the maybe line. There's a line reactance here, where we define as x1 and x2, where they have their own value, 10 with 5% and 8 with 4%. So first of all, remember, you need to find all the reactants in per unit. So per unit is same value. Okay, if you still remember, let's say we have the XX. So the original percentage, that percentage. So that percentage J means that percentage. Okay, multiply with S base over the original V base. Okay, so that original base. Okay, let's go. So xg1, because the value given is 10%. So where the value given for each MVA is 10, then you calculate 0.5. So same case with G2, 15%, 20 MVA, get J 0.275, and proceed with G3 and transmission line 1. So x1 is because they given 5%. Here is 5% and 4%. So 4%. So it depends on its value. So 10 MVA and 8 MVA. So you get this kind of value. Okay, this value. So you get this. So you get this at the first step. Okay. Okay, what's next? Okay, what's next determine how we deal with the question. So how we understand well. Okay, how we understand well. That's very, very, for me, it's very critical. Okay. Okay, it's quite critical here. So the solution here, for example, if you still remember, we have 3G3, right? Okay, for me first, let me write for you. Okay, we have G1, G2, and G3. Okay, so each G1, G2, and G3 have their own reactance. Okay, they have their own reactance. Alright. Oh, sorry, my bad. Okay, and then remember between that they have in the middle they have the line reactance. Okay, the line reactance. Oh, sorry, this is the reactance, not the resistance. So I write here xg1, xg2. Sometimes in the question they're asking you to write, to draw, to simplify, or to explain. So that's why you need to write this. Okay. So where is the fault? The fault happened here. So this fault. The fault is not happen here. So this for teacher. So next we need to simplify it. Okay, simplify it to become only one generator here, but with we like this kind of equivalent circuit. So where is the xg1, xg2, and this is xg3. So between that they have the xt1, xt2, then this is the, so this is the, okay, fault happen here. So fault, so it's the point where the fault happened. So here you need to solve the problem. Okay, solve the Thevenin technique. So you need to, the series thing that you need to add up, while the parallel, so you need to do the parallel one. Okay, so here means that you need to, this is series, so you need to sum up this. So this part means that xg3 plus xt2. Okay, so this is the xt2. Okay, we first sum up. Okay, let's proceed. Okay, proceed. I hope I still remember. I hope I still remember the picture. Alright, so this xg1, so xg2, then we get already another sum up of the reactance, where this part is still remain the same. So now this part already add up, where it's originally is the xg3 plus xt2. Okay, now become more understandable. So next, what's the next step? So the next step is to parallel. So these both are parallel. So let's say that I put this video as the xgt, xgt. Okay, so the xgt here. So what should we do? We need to, because this is parallel, so means that xg2 is now parallel with the xgt. Okay, understand? No? Okay, means that it's now become as a, so this next step. So finally we get the xg1. So xg1, this is a new value. So this is also a new value. Same value. So this is still the same f here. Okay, where this is the xg2, which parallel with the xgt. Okay, and this is remain as the xt1. Okay, so back to original values. I think we need to put values, if not we are going to make mistake. So I should put value in the first place, and just give you the idea, just try to make revision with you so that you can still remember the Thevenin technique. Okay, the Thevenin technique. So then we need to calculate lah. Okay, we need to calculate. But I think okay, I proceed. Let's allow me to proceed for the next one. Okay, for the next step. So you need to again. So it's now become series or parallel. So this now series. So number 5 now. Sorry, oh, this one is very bad. Sorry. Now become like this. Finally it become like xg1. It's only xg1 and new x. Sorry, so it's only xg1 and this is the series. So series means that, sorry for my bad handwriting. So this is the xt1 plus xg2, which is parallel is the xgt. Do you understand? Try to understand. Okay, try to understand. Right? So finally, at last. So, oh, sorry, already here. So this is just the value. That's the idea. I mean the basic without the put the values. So we just put the values. So it's same here. So we put all the values here. Then the process is come like this. Okay. Again. So these two are series. So you add both. Then finally, after you finish this add up, then this one become one value and it become only one value. After that, you parallel this value with this. So you parallelize it. So this is parallel. So that's why the parallel ones, if we refer from this slide, so they have calculated for us already. So it becomes J 0.2344. Okay, for all these three parts. So these three parts become J 0.2344, where this is remain. This is xt1. No, xt1 or xl1, whatever it is. Okay, xt1 is okay. Everything's okay. So you understand. Okay, this is the xg1. Okay, xg1. Right. So finally, like I told you, so this are going to become series. So you add up both. Then finally, you're going to parallel this and this. So it comes only one value. So we get here we got set form. Okay, where okay, it's the same value. Actually, even the right x part here is the same with the z. Why is the x? Because all are reactants and they don't include any resistance. Okay, that's why they call x fault. Actually, it's the same value with x fault. But because why they call it x fault? Because here they don't have the resistance. Okay, so SF, like I told you, you're going to parallel it with this and this and this. So that's why. So 0.5 you parallel. Okay, parallel and you get the x power as J 0.246 per unit. As usual, once you get the fault impedance or fault reactance, then simply calculate this S bar where that x fault is substituted here. Okay, this value. So this is the J 0.246 per unit. Then we already know the base MPa given in the question is 50. So put 50, then you get this kind of value 203.25 MPa. And finally, find the IF. So only this value is substitute where the given base MPa is 11 kV. So you just put the value and finally you get the current fault as 10.688 and the angle is minus 90 degree amps. Okay, the value is amps. It's not in per unit. Okay, not in per unit, but in amps or ampere. Okay,